Hello. 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 Okay. So, hi friends. Welcome to the Smart Crack series for NEET 2022. In this series, we pick up very important topics from each chapter of your NCERT physics book, and we understand the topic and we solve some problems based upon those topics. So, let's begin. Our today's topic is motion in a straight line. So, let's suppose that this is me and I go along this straight road. Okay, so let's suppose I start from this point A, I walk till this point B, I stop there, and then I return from that point and I go to the point C and stop. So I would like to define few terms regarding this motion. So terms are distance, displacement, average speed, average velocity, and acceleration. So what is distance? So distance covered is the total length of the path traveled. Okay, what is distance covered? It is total length of the path traveled. So we'll denote distance covered by letter D. Okay, so it is the distance from A to B and distance from B to C. Okay, so this length of the path from A to B plus length of the path from B to C. Okay, so it is SAB. I will write it here. So D is equal to what? SAB plus SBC. After that, what is the displacement? So displacement is the shortest distance between the start point and end point of the motion. And for this motion, I am going from A to B and then from B to C. So start point is A, end point is C, and the distance between them is what? Distance between A and C. Okay. So displacement I will denote by letter S. And what is S? So S is equal to what? Distance between start point, which is A, and C, which is the end point. All right. After that, what is average speed? So speed is distance covered divided by time taken, and average speed is the total distance covered divided by total time taken in a particular motion. So here average speed is distance covered D divided by time taken T. All right. Then next quantity is average velocity. So average velocity I will denote by letter V. And what is average velocity? So it is displacement divided by time. All right. And then the next term is the acceleration. So acceleration is defined as change in velocity divided by time. So acceleration A is equal to change in velocity per unit time. So it is some final velocity minus initial velocity divided by time. So final velocity is suppose v, initial velocity is u, and time is t. Then acceleration is given by v minus u divided by t. Okay, and all the quantities that we have defined are the average quantity. Okay, so these quantities need to be memorized for a particular motion. After that, let's proceed and let's see plotting of motion. Okay, so let's suppose we plot position or velocity or acceleration versus time. Okay, so position, velocity, acceleration on vertical axis and time on the horizontal axis. Then we get three kinds of graphs. One is position versus time graph, second is velocity versus time graph, and third one is acceleration versus time graph. So now let's see what kind of information do we get from these graphs? Okay, so let's consider the position versus time graph first. So for this particular motion, okay, this is me. I'm starting from this point A. A is my starting point. So I go from A to B. Okay, I stop. Then from T naught to time T1. So T1 is somewhere here. This is T1. So I'm going from A to B. Okay, and I'm stopping there. So you can see that the position, the change in position is positive. Okay, so if this is origin, then I'm going away from origin. All right, so change in position is positive. Okay, and then I stop at point B and I return from that point. So from T1 to T2, let's suppose from T1 to T2, I go back and stop at point C. So change in position would be what? It would be negative. Okay, so is it clear? I guess so. All right, so now in this motion, suppose I want to define the instantaneous velocity. Okay, I want to define what? The instantaneous velocity of me. Okay, because I am performing this motion. So let's consider some time. Let's call this time t, and suppose I want to find out the instantaneous velocity at this point. So what will I do? So I will draw a perpendicular from this point on the graph. It meets at this point, and then I will draw tangent to the graph at that point. Okay, so I will draw this tangent. Okay, so suppose this is a tangent, and the slope of this tangent will give me what? It will give me the instantaneous velocity at that point. Okay, so we know how to find slope. So let's suppose this is a line and I want to find out the slope of this line. All right, so suppose this is a line and I want to find out its slope. So what will I do? I can complete a triangle like this. Okay, then I know coordinates of this point. They are suppose x1 t1. Okay, actually it will be t1 x1, because if we take horizontal axis first, so t1 x1, and coordinates of this point will be t2 x2. So we know the change over vertical axis divided by change over horizontal axis is the slope. So what is slope? It is x2 minus x1 divided by t2 minus t1. Okay, I hope this is not going outside of the screen. Let me check. Oh, it's going out. Okay, so I will write it here. The slope is x2 minus x1 divided by t2 minus t1. Okay, and if I want to write this mathematically, okay, so if I want to write slope in terms of this curve, so what will be that? It is slope of the tangent line. Okay, and that slope gives me instantaneous velocity. So what is instantaneous velocity? Instantaneous velocity, it is velocity of an object at a particular instant of time. So mathematically we indicate that by derivatives. Okay, so we have learned this in 11th standard. So mathematically the slope is represented by derivative. Okay, slope of tangent line to a curve. Okay, so now it's not a time to derive all the things, so we'll just memorize this, that the instantaneous velocity is given by what? Slope of a tangent line to a curve, and mathematically it is derivative. Okay, so it is derivative of position with respect to time. All right. So that is instantaneous velocity, and this is about the position time graph. After that, so is there any question? If you have any question, you can ask me. No questions? Okay. So then let's move on to the next type of graph, which is velocity versus time graph. Okay. So suppose this is the velocity versus time graph for my motion. Okay. So this is the origin, and now what will happen if I take slope of the velocity versus time graph at a particular time? Okay. So we just saw that slope of position versus time graph gives me what? It gives me velocity, instantaneous velocity. Okay, slope of a tangent line to position versus time graph gives me instantaneous velocity. So let's suppose I take some time t, and I draw a perpendicular on velocity versus time graph from that time, so it meets at this point. And if I draw a tangent at this point, so what will the slope of this tangent give? So it gives what? It gives instantaneous acceleration. Okay. So change in position with respect to time is velocity. Change in velocity with respect to time is acceleration. So this slope will give what? Instantaneous acceleration. Okay, A, and it is mathematically just like mathematically velocity, instantaneous velocity is derivative of position with respect to time. Mathematically, instantaneous acceleration is what? Derivative of velocity with respect to time. Okay, so it is dv by dt. All right. After that, we get one more information from the velocity versus time graph, and that is we get the displacement. Okay, so let's see how. So if we consider this simple velocity versus time graph, so we know this is velocity versus time graph for constant velocity, okay, for uniform motion. So here velocity is constant, and I can write this velocity as what? Change in position x2 minus x1 divided by t2 minus t1. Okay, so let's suppose I take some time t1 over here and t2 over here. So what will be v? So v is position at time t2 minus position at time t1 divided by t2 minus t1. Okay, and now if I take this t2 minus t1 on the other side, what do I get? I get x2 minus x1, which is displacement. Okay, so we know displacement is final position minus initial position, and we can write it as v times t2 minus t1. Okay, and if you look that over here, if you observe here, so this much length is what? It is v. Okay, this is distance from 0 to v. All right, and this much length is t2 minus t1. So area under this curve is what? Length times breadth. That means it is t2 minus t1 multiplied by v, and it is precisely this thing. Okay, so that means that the area under the velocity versus time graph gives me what? It gives me change in position or displacement. Okay, so I can write that. So area under velocity versus time graph gives displacement. Okay, and we can apply same logic over here. So if we pick some time let's say t1, okay, and some other time t2, and I want to find out the displacement of this object whose velocity versus time graph is this one. So I want to find out the displacement of that object in time t1 to t2. Okay, so what do I do? I will find out the area under this graph. Okay, so in earlier case, in this case, finding out area was simple. It is just a rectangle. So its area is length multiplied by breadth. But in this case, it's not a rectangle. So how do we find area under such a curve? I'm sorry. Sorry. Okay. So how do we find area under such a curve? So what we do is we imply integration. Okay. So what I will do is I will write dv equals to what? A times, sorry, I'll write v equals to what? dx by dt, and I will take dt on the other side. So what do I get? I get dx equals to v times dt. And if I integrate this, so if I integrate this from time t1 to time t2, what do I get? So I get area under this curve. Okay, so area under velocity versus time graph gives me what? It gives me displacement. And what is the meaning of area under velocity versus time graph? The meaning of that is integration of velocity, okay, with respect to time. All right, so I will integrate velocity from time t1 to time t2, and it will give me what? The change in position or displacement. So this is from x1 to x. Okay, so this is simple. Area under the velocity versus time graph gives me displacement. So this is about the velocity versus time graph, and now we are left with one more graph, that is acceleration versus time graph. Okay, so again it's simple. So here let's suppose I consider time t1 and time t2. So instantaneous acceleration a can be written as what? It is dv by dt. We just saw. Okay, so now I want to find out the change in velocity. Okay, so I can take dt on the other side. So I will write dv equals to a dt, and then I will integrate this. Okay, so this integration now, so integration of dv is equal to what? Integration of a dt. I will take it from time t1 to t2, and that will give me change in velocity. Okay, and what does that indicate on this graph? So just like the integration of v dt is area under the velocity versus time graph, just like that integration of a dt from t1 to t2 gives me what? It gives me area under the acceleration versus time graph. Okay, so this integration gives me area under acceleration versus time graph, and this integration means the change in velocity. v2 minus v1 is equal to, okay, so I will write area under AT graph gives change in velocity. All right, so is there any question? Okay, after that there is one more important topic in motion in a straight line, and that is uniformly accelerated motion. So what is uniformly accelerated motion? It is motion with constant acceleration, with uniform acceleration. So suppose acceleration is constant. So if we consider the acceleration is constant, then we get three kinematic equations. And what are they? So three kinematic equations are, first one is v is equal to u plus at. Second equation is s equals to ut plus half at square. Third equation is v square equals to u square plus 2 times a into s. Okay, so we get these three kinematic equations of motion for uniformly accelerated motion. And what do they mean? So v is final velocity. Okay, u is initial velocity. So final velocity equals to what? Initial velocity plus acceleration into time. Okay, that is the first equation. S is displacement. So that displacement is ut plus half at square. Okay, u is initial velocity, t is time, and a is acceleration. Then v is final velocity. So third kinematic equation is v square equals to u square plus 2 times a into s. Okay, and after that we need to remember one more thing, that average velocity in uniformly accelerated motion can be written as u plus v divided by 2. It is just initial velocity plus final velocity divided by 2. Okay, it's very simple. After that, this is Galileo's law of odd numbers, and it's a trick. Okay, it's very simple and it will come in very handy when we solve problems. So what is Galileo's law of odd numbers? So let's suppose there is an object performing uniform circular motion. Okay, sorry, object is performing uniformly accelerated motion. So a is constant. For an example, let's suppose I take a ball, I drop it. Okay, so it is falling freely under gravity. All right, so what is acceleration in this case? Acceleration is acceleration due to gravity. So now in this case, let's suppose the ball travels some distance in some time, and we break that time in equal time intervals. Okay, so total time is suppose t, and I break it in equal time intervals. So this time interval is t. I'm breaking it like this in equal time intervals. So this is suppose first time interval, this is second time interval, this is third time interval, so on and so forth. All right, so now suppose the distances covered in these time intervals are s1, s2, s3, so on and so forth up to sn. Okay, so now Galileo's law of odd numbers gives us direct relation between these distances. Okay, so s1 is distance covered in first time interval, s2 is distance covered in second time interval, s3 is distance covered in third time interval, so on and so forth. All right, so Galileo's law of odd numbers gives us the ratio of these distances. So s1 is to s2 is to s3, so on and so forth, is equal to 1 is to 3 is to 5 is to 7 and so on. All right, so we need not solve for the distances, we get direct ratio of the distances covered in equal time intervals. Okay, so yeah, um, Shifana is asking, sir, I am a repeater but I didn't study physics. Is it possible to finish physics in those in less time? Yeah, so what you can do is you can focus on repeatedly asked questions mostly. Okay, so don't solve them directly. What you can do, focus on the concepts uh, which are repeatedly asked, the questions or those concepts are repeatedly asked in the exam, and try to understand them and try solving questions on those concepts. Okay, all right, So I hope Galileo's law of odd numbers is clear. Okay, so you will be surprised. This simple law, it is like I guess 3 to 4 times the questions were asked on this law. Okay, so we'll see them. And the last topic that we need to remember is of relative velocity. So what is relative velocity? So let's suppose there are these two cars moving on a straight road, okay, car A and car B, and the relative velocity of car B with respect to A is denoted as VBA, and it is just velocity of car B minus velocity of car A. Okay, and suppose at some time the relative distance between those two cars is this much, it is suppose S. So now if velocity of car B is more compared to velocity of car A, so in some time, let's say t, car B will overtake car A. So what is that time? So how can we find that? So the relative distance is equal to the relative velocity multiplied by time. Alright, then this is simple motion. Both cars are moving with uniform velocity. There can be a condition when both cars are accelerating. So in that case, the relative, in case of acceleration, we have to consider relative acceleration also. A, B, A is the acceleration of B, car B with respect to A, and that will be acceleration of car B minus acceleration of car A. Okay, then we can write down as the distance covered. This is the relative distance between these two cars, and suppose it is covered in time t. So we can write that it's equal to VBA times t plus half of ABA times t square, just like our uniformly accelerated motion. Okay, so this is all the theory that we need to remember in case of the motion in a straight line in order to be able to solve the problems. Okay, yeah, I have taken full chapter on YouTube. You can check that. All right, so now we'll solve some problems based upon motion in a straight line. So let's move on to the problems. Okay, so first problem is a car moves from x to y with uniform speed vu and returns to x with uniform speed vd. Okay, the average speed for this round trip is, so there is a car which moves from x to y with speed vu and it returns from y to x with speed vd. Okay, so suppose distance between x and y is s. So what will be time taken to go from x to y? We know time is equal to what? Let's call it t1, time to go from x to y. It is distance covered divided by velocity. So s divided by vu. Time taken to go from y to x will be what? Suppose it's t2, so it is s divided by velocity, which is vd. And now how can we find out the average speed for this round trip? So average speed, we know it is what? Total distance covered. So what is total distance covered? It goes from x to y, that is s. From y to x, it is another s. So s plus s is the total distance covered divided by total time taken. So what will be total time? t1 plus t2. Okay, so that is 2s divided by s upon vu plus s upon vd. Okay, t1 is s upon vu, t2 is s upon vd. And then we can simplify this. So I will simplify this. V average equals to 2s divided by, in denominator I will take s common. So what I'm left with is 1 upon Vu plus 1 upon Vd. Okay, and then S will get cancelled and we are left with 2 divided by. Now we can make denominator of these two terms common. Okay, so we can multiply first term with Vd and second term with Vu. Okay, so what do we get? So we I'm sorry again. We get Vd upon Vu times Vd plus here it will be 1 multiplied by Vu, so Vu. Okay, and this is denominator of denominator, so we can take that into the numerator. So we get V average equals to 2 times of Vu times Vd divided by Vu plus Vd. Alright, so this is the answer. Let's check. It matches with option D. Okay, so it's very simple. Is there any question? Okay, so let's move on to the next problem. Next problem is a car runs at a constant speed on circular track of radius 100 meters, taking 62.8 seconds for every circular lap. Okay, so we are given r equals to 100 meters and the time period. Time period is what? 62.8 seconds. Then the average velocity and average speed for each circular lap is respectively is. So we need to find out average velocity and average speed. So now clearly what will be average velocity in case of circular motion? So if a body performs circular motion, in each revolution it returns to the same position from where it started, right? So average velocity must be 0, okay, in each and every revolution, because what? The displacement is 0. It starts at same point, ends at same point, okay? So let's check in which options the displacement is 0. So it's option B and option C, okay? And then what is average speed? So clearly now average speed cannot be equal to 0, okay, because it will cover some distance. What is average speed? This total distance covered divided by total time taken. So it cannot be equal to 0. So this cannot be the answer. So if you ask me, we need not even solve this. So this will be the answer, okay, and we can just check. Okay, let's solve and check. So what is average speed in circular motion? It is 2 pi r divided by t. Okay, so time period is given, it is 62.8, and we can write pi equals to 3.14, r equals to 100. So it is 3.14 times 2 will be 6.28. 6.28 multiplied by 100 will be what? 628. So 628 divided by 62.8 is 10 meters per second. Alright, so again it matches with option C. Okay, so if there is question like this, we need not even solve it. So the average speed cannot be equal to 0. It is common sense, right? Okay, let's move on to the next problem. So next problem is two cars P and Q start from a point at the same time in straight line and their positions are represented by. So position of P is represented by this thing, okay, AT plus BT square, and position of Q is represented by FT minus T square. At what time do the cars have same velocity? This is the question. Okay, so again it's simple. What is velocity? It is derivative of position with respect to time. Okay, so now here we need to know the formulae for derivatives. Okay, so let's suppose they have same velocity at some time t. So velocity of p is equal to velocity of q. So what is velocity of p? It is derivative of position of p with respect to time. What is velocity of q? It is derivative of position of q with respect to time. Okay, that is d by dt of what is position of p? It is at plus bt square. A times t plus bt square, and it's equal to d by dt of position of q. It is ft minus t square. Okay, so then let's solve it. So after that, what is derivative of this thing? At minus bt square. So if you take derivative of this thing at, what was that? Plus bt square. Plus bt square equals to derivative of ft minus t square. So d by dt of ft minus t square. Let's solve it. So it is a is constant, we can take it outside. Derivative of t with respect to t is 1. Okay, so it is a plus what is derivative of bt square? So b also we can take outside. Derivative of t square with respect to t. So I hope you know this. The formula is derivative d by dt of t raised to n is equal to n multiplied by t raised to n minus 1. This is the formula. Okay, so here we have what? T square. Okay, so t to the power 2. So our n is 2 in this case. So what will happen? What is its derivative? So 2 multiplied by t raised to 2 minus 1. Okay, 2 minus 1 is 1. Okay, so it is equal to b multiplied by 2 into t raised to 2 minus 1, that's 1. Okay, so 2t. And on right hand side we have derivative of ft minus t square. So now f is constant, we can take it outside. Derivative of t is 1, so f multiplied by 1 minus derivative of t square, we just saw it is what? 2 times t. Okay, so I will erase this thing. So f minus 2t. Okay, again, so we can take this 2t on other side and a on this side. So we get b times 2t minus, okay, it will be plus 2t equals to f plus b, f plus a, and we can take 2t common, or let's take t common only. So t equals to, okay, so here we are left with 2b plus 2, not 1, 2b plus 2. It is f plus a. I have taken t common. So t will be equal to what? F plus a divided by 2b plus 2. This is the answer. Let's check. Okay, so it is option C. So 2 is also taken common. Alright. Yes. So Mohammad Zubair. Yeah, hi Mohammad Zubair. How are you? So is there any question? No questions? Alright. So let's move on to the next problem. Next problem is, if the velocity of a particle is v equals to at plus bt square. Sir, you take full lesson. Yes, this is crash course. So this is one short lecture for motion in a straight line. All right. So we already covered theory in this lecture, and now we are solving some problems. Okay. So let's see this problem. if the velocity of a particle is v equals to at plus bt square, where a and b are constants, then the distance traveled by it between 1 second and 2 second is. Okay. So velocity is given by this thing, and we are asked what is the distance traveled by it from 1 second and 2 seconds. So we saw this in theory. Okay. What is displacement in terms of velocity? So s is equal to integral of v dt, if v is given in terms of t, from time t1 to t2. Okay. So let's substitute formula for v and values of t1 and t2. So let's do that. T1 is 1 second and t2 is 2 seconds. So we have integral of a times t plus b times t square from 1 to 2. Okay. And we can separate this because there is a plus sign in between. So we have what? Integral of at and bt square. So s is equal to integral of at dt from t1 to t2, that's 1 to 2, plus bt square. Okay. And a and b are constants, so we can take them outside of integral. So it is integral of t dt from 1 to 2, plus b also we can take it outside, so integral from 1 to 2 of t square dt. Okay. And then we have integral of t. What is integral of t? So for integrals we need to memorize this thing. Integral of, let's say, t raised to n dt is equal to t raised to n plus 1 divided by n plus 1. So the limits are, suppose, t1 to t2. Here also limits will be from t1 to t2. Lower limit is t1, upper limit is t2. Okay. So here the value of n is 1 because it's just t. Okay. So what is integral of this? It will be t raised to 1 plus 1 divided by 1 plus 1, and 1 plus 1 is 2. So t square upon 2 from 1 to 2, plus here we have b multiplied by integral of t square dt. So our n here is 2. So what will be integral? T raised to 2 plus 1 divided by 2 plus 1, that is 3, t cube upon 3. Okay, from 1 to 2. And now let's substitute the units. Okay, sorry, the limits, upper limit and lower limit and upper limit. So it is equal to a times, let's substitute upper limit is 2. We can take this 2 from denominator outside, so it is t square. Okay, 2 square minus 1 square from here, and it is b by 3. We are taking this t 3 outside, so it is t cube. Okay, and our upper limit is 2, so 2 cube minus 1 cube. Okay, so it is what? 2 square is 4, 4 minus 1 is 3, 3 by 2 a, plus, I hope you can see this. Let me check. Yes, it's going little bit outside of the screen, so let's write it on next page. Okay, so from first term it is 3 by 2 a, plus from second term we have 2 cube is 8, 8 minus 1 cube is 1. Okay, so 8 minus 1 is 7, so 7 by 3 b. Okay, so answer is how much? It is 3 by 2 a plus 7 by 3 b. 7 by 3 b. This should be the answer. Okay, so option A is the answer. Alright, that's simple. Then again, let's move on to the next problem. A particle shows distance time curve as given in this figure. So it shows distance versus time curve as shown in this figure, and the maximum instantaneous velocity of particle is around the point. So where will be the maximum instantaneous velocity? So we know that instantaneous velocity is slope of tangent to the position versus time graph. Okay, so the instantaneous velocity will be maximum where the slope of tangent is maximum. Okay, and let's try drawing tangents at point A. At point B, it will be something like this. If this is point C, it is something like this, and point D is somewhere here, so it's something like this. Okay, so as my eyes can see, it should be option C. Okay, it is the steepest one. All right, but your eyes can betray you, so be careful. So option C, you draw a tangent at each and every point and you see at which point the slope of the tangent is maximum. At that point, the instantaneous velocity will be maximum. Okay, it's very simple. Let's move on to the next problem. The position x of a particle with respect to time t along x-axis is given by x is equal to 9t square minus t cube, where x is in meters and t in seconds. What will be the position of this particle when it achieves maximum speed along the x direction? Okay, the position of particle with respect to time is given by this thing. Then what will be position of particle when it achieves the maximum speed? So this is the problem on maxima and minima. Okay, so let's suppose this is the position versus time graph, and at some point the slope is maximum. Okay, so what will happen? So velocity is given by what? Dx by dt, right? Okay, so velocity is I'm sorry, it is d by dt of what? 9t square minus t cube. Okay, and then you can take this derivative. What will you get? So it is 9 times derivative of t square with respect to t. So d by dt of t square minus derivative of t cube with respect to t. So what is derivative of t square? Let's add a page. What is derivative of t square? It is 2t. Okay, so we just saw this formula. Derivative of t raised to n is equal to what? N times t raised to n minus 1. So derivative of t raised to 2 will be what? Here n is 2, so it is 2 times t raised to 2 minus 1. Okay, that's 1. All right, so it is 9 times 2t, 9 multiplied by 2t, and minus we have derivative of t cube, so d by dt of t raised to 3 equals to, okay, so it is 3t square. So let's substitute that, 3t square. All right, so this is the velocity. And what's the question? Question is, what will be the position of this particle when it achieves maximum speed, okay, in the x direction? So Okay, I want maximum speed. So now what I will do is I will take one more derivative. Okay, so dv by dt. So if you take dv by dt, what do you get? This is 9 times 2, 18t minus 3t square. Okay, and I want to take derivative of this. I will explain why I am doing this. Okay, just one second. d by dt of v is d by dt of this thing. Okay, so derivative of this thing, you can take 18 outside. So you will get 18 times derivative of t with respect to t is 1. Okay, minus here 3 you can take outside, derivative of t square is 2 times t. Okay, so it is dv by dt. Alright, that is acceleration. So now if you draw velocity versus time graph, okay, now be careful here. I will draw velocity versus time graph, v versus t graph. Okay, so let's suppose it is something like this. So where is the velocity maximum? It's maximum at this point. Okay, and what is slope of this graph at this point? So slope is 0. Okay, so velocity keeps on increasing, increasing and increasing, and it becomes maximum at some point and then it starts decreasing. So if you draw tangent at that point, what will you get? The slope of that tangent will give you acceleration. Okay, so slope at this point is 0. All right, so that means acceleration at this point should be equal to what? 0. Okay, so acceleration is 0. Let's substitute 0 over here. So it is 18 minus 32t. So 32t can be, was it 32? Oh, sorry, it was 3 times 2, not 32. Okay, so 3 times 2 is 6. 60 we can take on other side. So we get 60 equals to 18. So t equals to what? 18 divided by 6. And that is 3 seconds. And we are asked, this is somewhat lengthy question. So we are asked, what is the position? Okay, so we have to substitute t equals to 3 seconds in the formula for the position. So x is equal to what? I will erase this, I will write it here only. We found t is equal to 3 seconds is the time when velocity is maximum. So position x is equal to 9t square minus t cube. So 9 multiplied by t square, that is 3 square minus 3 cube. Okay, t is equal to 3. So 3 square is 9, 9 times 9 is how much? It is 81 minus 3 cube is 27. So 81 minus 27. So I guess 54 should be the answer. Okay. Alright. So is this clear? This was somewhat lengthy and tricky question. Okay. I hope this is clear. Okay. So let's move on to the next problem. Alright. So this was problem from 2007. Okay. So in those times, it was starting time for NEET. So some next question. Yeah. So in those times, the difficulty level of NEET was somewhat higher. Okay. Alright. So let's move on to the next problem. The displacement x of a particle varies with time t x as x equal to a into e raised to minus alpha t plus b into e raised to beta t, where a, b, alpha and beta are positive constants. The velocity of particle will. Okay. Option A is b, independent of beta. Option B, drop to 0 when alpha equals to beta. So see, question is based on velocity and we are given with formula for x. So it is a into e raised to minus alpha t plus b into e raised to beta t. Okay. So question is based on velocity. That means we need to take what? Derivative of position. Okay. So let's do that. So velocity is dx by dt, and that's equal to, here now, derivative d by dt of e raised to, let's say, at. The formula for this is a multiplied by e raised to at. Okay. So here, what is value of this a? It is minus alpha. So derivative here will be this a multiplied by minus alpha into e raised to minus alpha t. Okay. And derivative of the second term will be what? So here we have b into the exponent multiple is beta, coefficient is beta. So it is b into beta into e raised to beta t. Okay. So now we got the formula for velocity, and here, see, now let's check the options. So it is independent of beta. Is it independent of beta? Clearly not, because as you change beta, the velocity will change. So option A cannot be the answer. Then it dropped to 0 when alpha equals to beta. We can check this. Does it drop to 0 when alpha equals to beta? It cannot drop, because let's say alpha equals to beta. So alpha equals to beta. I will substitute beta in place of alpha. So what do I get? Minus of a into beta e raised to minus beta, because I will substitute beta for alpha. So plus we have b into beta e raised to beta t. Okay. So now you can take beta common. So even if you take beta common, okay, I can write this as what happened. Where is my question? It's here. I'm sorry. Okay. So I was saying we'll take beta common. Okay. So if you take beta common, you are left with what? Minus a e raised to minus beta t plus b into e raised to beta t. Okay. B e raised to beta t. All right. So does it drop to 0? Obviously not. Okay. Because even if alpha is equal to beta, see, a, it depends on the values of a and b, and even if those two values are equal, one of these terms is decreasing and the other term is increasing. But considering beta is positive, okay, considering beta is positive, what will be minimum value of this term? It will be 0. Okay. What is the maximum value of this term? As t goes on increasing, what will happen? This term will drop to 0, because the exponent is negative. Okay. And this term will keep on increasing. So at t equals to infinity, if you think, this term will drop to 0, and what will happen to the other term? It will keep on increasing, right? Because beta is positive, so the exponent is positive, so t increases, this term will keep on increasing, right? So it will never drop to 0. That's not an option. Okay. So option C is also not correct. It doesn't decrease with time. So option D has to be correct. It keeps on increasing with time. Okay. Is it clear? Is it clear? I think there is some lag between what I say and the All right, so again, let's move on to the next problem. Next problem is a particle moves a distance x in time t according to the equation x equal to t plus 5 raised to minus 1. The acceleration of particle is proportional to. Okay, okay, good. Mohammad Zubair is saying yes sir, and Bharti is also saying yes sir. Okay, so we have this question: x is equal to t plus 5 raised to minus 1. This can be written as what? 1 upon t plus 5. Okay, so options are acceleration of particle is proportional to velocity to the power 3 by 2, or distance square, or distance raised to minus 2, or velocity raised to 2 by 3. So let's try to solve this. So we have to find velocity also and acceleration also. Okay, because yeah, we need to find acceleration only. Okay, so dx by dt gives me velocity, and it will be derivative of this thing. So derivative of 1 upon t plus 5 will be, so derivative of 1 over t is minus 1 over t square. Okay, so if I write this as, see, derivative of t plus 5. So 5 is constant, so derivative of 5 will be 0. Okay, so derivative of t plus 5 raised to minus 1 is analogous to derivative of t raised to minus 1. So what is derivative of t raised to minus 1? So if you take derivative of this using our formula, n into t raised to n minus 1, the value of n here is what? Minus 1. So it is minus 1 into t raised to what? Minus 1 minus 1, that's minus 2. Okay, the value of n here is minus 1. So derivative of t raised to n is n into t raised to n minus 1. Okay, value of n is minus 1. So it is minus 1 into t raised to minus 1, that's minus 2. Okay, so here we'll get minus 2. So likewise, the derivative of this thing t plus 5 raised to minus 1 will be what? It is minus 1 upon t plus 5 raised to 2. Okay, or I just wrote minus 1 into t plus 5 raised to minus 2, like this. T plus 5 raised to minus 2 in numerator is t plus 5 raised to 2 in the denominator. So this is v, and we want what? We want acceleration. Okay, so we need to take one more derivative. So let's take one more derivative. Okay, so the formula for v is minus 1 upon t plus 5 raised to 2. So we want acceleration. It is dv by dt. It's equal to derivative of minus 1 upon t plus 5 raised to 2. So let's take this derivative. What do we get? So again, I can write this as minus 1 I can take out, and it is d by dt of t plus 5 raised to minus 2. Okay, so value of n here is minus 2. So derivative will be minus 1 multiplied by this minus 2 into t plus 5 raised to minus 3. Okay, the value of n is minus 2. So it is n, which is minus 2, multiplied by t plus 5 raised to n minus 1. N minus 1 is n minus 1 what? It is minus 2 minus 1, that's minus 3. Okay, so what do we get? So it is 2 times minus 2 times minus 1 is 2, and this can be written like what? It can be written like 1 upon t plus 5 raised to 3. Now let's check the options. So option is it velocity raised to 3 by 2? Is it proportional to velocity raised to 3 by 2, or distance raised to 2? So distance raised to 2 is clearly not correct, because in distance we have 1 upon t plus 5. Okay, or you can say, I will erase this thing. So formula for distance is what? X is equal to t plus 5 raised to minus 1. Formula for the velocity is minus 1 into t plus 5 raised to minus 2. And formula for acceleration is what? It is some constant 2 multiplied by t plus 5 raised to minus 3. Okay, so see, uh, distance square is not correct because if you square distance, what will you get? T plus 5 raised to minus 2. Okay, right? Square of this. That's not correct. So distance raised to minus 2 is also not correct, because if you square that, what will you get? T, if you take t plus 5 raised to minus 1 raised to minus 2, you will get t plus 5 raised to 2. So that's also not correct. So either this one or this one. Let's check that. So the formula for velocity is t plus 5 raised to minus 2, and formula for acceleration is t plus 5 raised to minus 3. So now see here, if I take this formula for velocity, okay, I want what? T plus 5 raised to minus 3. So what will I do is, I will take this formula for velocity t plus 5 raised to minus 2, and if I multiply this with 3 by 2, okay, so this 2 and 2 gets cancelled, right? So what do I get? T plus 5 raised to minus 3, right? Please see, what I am doing is, I have this formula for velocity. It depends on t plus 5 raised to minus 2. What I am doing is, I am obtaining formula for acceleration from this formula. Okay, so t plus 5 raised to minus 2. So I want minus 3. So what I will do is, I will multiply by 3 and divide by 2. Okay, so it is velocity raised to the power what? 3 by 2. It is proportional to velocity to the power 3 by 2, because if this 2 and 2 gets cancelled, okay, if we raise formula of velocity to the power 3 by 2, what do we get? This 2 and 2 gets cancelled, so we get t plus 5 raised to minus 3, right? And that's our acceleration. So option, which one? Option A is the correct answer. Okay, is it clear? Is it clear? Okay, so let's move on to the next problem. So next problem is, a particle moving along x-axis has acceleration f at time t, uh, given by f equals to this thing, where f naught and t are constants. The particle at t equals to 0 has 0 velocity in time interval from t equals to 0 and instant when f equal to 0. The particle's velocity vx is, okay. So we are given with the formula for acceleration, okay, and we want to find out particle's velocity. So what do we do? So we are given acceleration equals to f naught 1 minus t by t, okay, and question is, in time interval between t equals to 0 and instant when f is equal to 0. Okay, f means this acceleration equals to 0. So let's find out when this acceleration becomes 0. Okay, so this is 0, means f0 1 minus t by t is 0. So f0 we can take on other side. Okay, so that multiplied by 0, it will go in denominator, but 0 divided by anything is also 0. Then 1 minus t by t, 1 minus t by t equals to 0. So we take that t by t, small t upon capital T, on other side. So we get 1 equals to small t divided by capital T, and it gives t equals to what? Capital T. Okay, so at t equals to capital T, what happens? This acceleration becomes what? 0. Okay, f becomes 0. So we are asked, in the time interval between t equals to 0 and instant when f is equal to 0, the particle's velocity is. Okay, so how do we find velocity given acceleration? So we know a equals to dv by dt. So we just saw it in theory. So dv equals to a dt. Okay, dt you can take other side, and we can integrate it from t1 to t2, and this one also from t1 to t2. Okay, so from v1 to v2. So we'll get integral of dv equals to what? Final velocity minus initial velocity equals to integral of this thing, integral from t1 to t2 of a dt. Okay, and then we can substitute the formula for a given in the equation, given in the question. What is that formula? The formula is f naught 1 minus small t upon capital T. Okay, so let's substitute that here. So if you substitute that, f naught 1 minus small t upon capital T, and we have to integrate this from t equals to 0 to the time when f becomes 0, and we found out that time when f becomes 0, it is equal to capital T. Alright, so let's substitute that from 0 to capital T. We have to integrate this. Okay, so initial velocity is 0, it is given in the problem. Okay, so v2 equals to what? We'll find out. Okay, so f naught we can take outside of the integral. So we have integral from 0 to t of this thing. We can separate it. It is integral of 1 dt minus integral from 0 to t of t upon capital T dt. Because there is minus sign in here, I have separated it in two integrals. Okay, integral of 1 dt minus integral of t by capital T dt. Okay, so again, now what is integral of 1 dt? Sorry, integral of 1 dt, it is t. So you have f naught into t, and what are limits from 0 to capital T. Okay, and what about in another integral? So here again you have this capital T, which is constant. You can take that outside. So it is minus 1 by capital T integral from 0 to t of t dt. So what is integral of t dt? It is integral of t raised to 1 dt, and we have seen this integral of t raised to n dt is what? T raised to n plus 1 divided by n plus 1. So here value of n is equal to 1. So it is t raised to 1 plus 1, that's 2 upon 2, and the limits are from 0 to capital T. Okay, so v2 is equal to vx. It's given there. They are calling the final velocity as vx. Okay, and then we can substitute upper and lower limits. So what do we get? Here if we substitute upper limit, it's capital T, so it is f naught times t. So vx is f naught times t minus 1 by t of upper limit is t, lower limit is 0, so it is capital T square upon 2 minus 0, that is t square upon 2. Okay, so it is f naught into capital T minus this thing gets cancelled, minus t by 2. So this should be the answer. So let's check the options. Okay, did I do some? Yeah, I missed F naught here. Okay, so this F naught was in multiplication. It is coefficient of both the terms, right? So I just multiplied first term with it. So we have to multiply the second term also. F naught, F naught, and F naught or here also. Okay, here also. So F naught into T by 2. So F naught you can take common again. So it is T minus T by 2. How much? F naught into T by 2. Okay, so there was a silly mistake and option C is the answer. All right, so this is again a simple question. I hope this is clear. Okay, let's move on to the next problem. Next problem is a ball thrown vertically downward with a velocity 20 meters per second from the top of the tower. Okay, it hits the ground after some time with velocity 80 meters per second. Ball is dropped, it hits the ground with velocity 80 meters per second. The height of the tower is, okay, so u is equal to what? 20 meters per second. It's given initial velocity is 20 meters per second. Final velocity with which it drops on the ground, v is equal to 80 meters per second. It is given, and we are asked what is the height of the tower, and take g equals to 10 meter per second square. So this is simple problem. We know the kinematic equation of motion, v square equals to u square plus 2as. Okay, so v square equals to u square plus 2 times as, or we can write this as, if we take u square on other side, it can be written as v square minus u square equals to 2 times a into s. We can take 2a on the other side. Okay, it goes in denominator. So s is equal to v square minus u square divided by 2a. And how much is a? In free fall, the ball is falling freely under gravity. So a is equal to acceleration due to gravity. Okay, so we can substitute that. A is equal to g, and that is 10. So let's substitute the values. So v is 80. We have 80 square minus 20 square divided by, in denominator, 2 times of 10. Okay, so 2 times of 10 is 20. We can take 20 common from the numerator. So if I take 20 common from numerator, what do I get? Okay, to save for calculations. So if I take 20 common, 80 is 20 times 4. Okay, I have taken 20 common because I have 20 in the denominator. So from this first term, 80 is 20 times 4. So I'm left with 4 square. And from the second term, it is 20 square, and I'm taking 20 common. So I'm left with 1 square. So minus 1 square. Okay, so 20 by 20 is 1. 4 square is 16. Minus 1 square is 1. So 16 minus 1 is what? 15. So answer is 15 meters. All right. Answer has to be 15 meters. It's not. But let us check our calculations again. So it is 20 meters per second from top of a tower. It hits the ground after some time with velocity 80 meters per second. Okay, and height of the tower is g equals to 10 meter per second square. So we have v square minus u square equals to 2 times a into s. S is equal to, if we take 2a on the other side, v square minus u square upon 2a. That's correct. So in numerator we have what? 80 square minus 20 square. Oh, yeah, I did a mistake. I'm sorry. It is 20 square that we can take common. It's not 20, right? Oh, okay. So then one of the 20s get cancelled. Okay, and we are left with 20 times 15 in the numerator, and 20 times 15 is how much? It's 300. Okay, so I'm sorry for the silly mistake. So answer is 300 meters. Okay, yeah, it was very simple question, but yeah, my silly mistake. How silly I am. All right, let's move on to the next question. So a stone falls freely under gravity. It covers distances h1, h2, h3 in the first 5 seconds, the next 5 seconds, and next 5 seconds. Do you remember the Galileo's law of odd numbers that I taught some time back? Okay, so this is question based upon that. Direct question. The relation between h1, h2, and h3 is, see, the stone is falling freely under gravity. Okay, so acceleration is constant, and for constant acceleration, what does the Galileo's law of odd numbers says? The If you divide the total time in equal time intervals, if you take equal time intervals, then the distance covered in first time interval, okay, so time intervals are suppose t1, t2, t3, and distances covered are s1, s2, s3. Okay, so if you have positive acceleration and if you take equal time intervals, then the distances covered in those time intervals are in the ratio of what? Odd numbers, 1 is to 3 is to 5, so on and so forth. All right, so that means here it's height. So what s2 or h2 equals to how much? S1 is to s2, or let's replace this with heights. Okay, h1 is to h2 is to h3. Okay, so h2 equals to how much? I can write h2 equals to 3 times of h1. Okay, and h3 equals to how much? It is 5 times of h1. Okay, so now you can find out h1 from here. So h1 equals to how much? H1 equals to, take 3 on other side, it is h2 divided by 3. Okay, and from here you can find out h1, it is h3 divided by 5. So option D is the answer, directly based upon the Galileo's law of odd numbers. And if you solve this, then your 10 minutes, okay, are gone. So you can solve 3 more questions, 3 to 4 more questions in the same time. Is it clear? See, this is a direct question based upon Galileo's law of odd numbers. Okay, and it is this easy. You need not solve it. I hope this is clear. Okay, we can directly guess the answer. We need not do the lengthy procedure of solving. All right, let's move on to the next problem. Next problem is a boy standing at the top of tower, 20-meter height, drops a stone. Assuming g equals to 10 meters per second square, the velocity with which it hits the ground is. This is straightforward question. Okay, so what we have, v square equals to u square plus 2 times a into s. The boy drops a stone. Okay, so its initial velocity is 0. Acceleration is acceleration due to gravity. Let's take it, it's given, consider it as 10 meters per second square multiplied by the distance is 20 meters. Okay, so multiplied by 20. So it is 20 times 2, 40. 40 times 10 is 400. So v square equals to 400. So what is v? V equals to square root of that, 20 meters per second is the answer. Option B. Okay, very simple. Then let's move on to another problem. A particle starts its motion from rest under action of constant force. Okay, constant force means constant acceleration. Okay, then if the distance covered in first 10 seconds is s1 and that covered in first 20 seconds is s2, then okay, distance covered in first 10 seconds is s1 and in first 20 seconds is s2. Again, recall Galileo's law of odd numbers. So constant acceleration, then the distance is covered. Let's say we take time intervals t1, t2, t3, so on and so forth, and distances covered are s1, s2, s3, so on and so forth. Then what is the ratio of those distances covered? So from Galileo's law of odd numbers, it is 1 is to 3 is to 5 and so on. So here we have to find out the relation between S1 and S2 only. So what is S1 is to S2 according to Galileo's law? It is 1 is to 3. Okay, and this holds for constant force or constant acceleration only. Okay, so S2 is 3 times S1. Straightforward answer. Okay, need not solve. It is we just have to get the answer based upon what? Galileo's law of odd numbers. Okay, so I'm telling this once again. So if you have a uniformly accelerated motion or motion under a constant force, then if you take equal time intervals, okay, then the distance covered by the body in those equal time intervals is in the ratio of 1 is to 3 is to 5 and so on. Okay, this is Galileo's law of odd numbers, and that's why now here see the particle is moving from rest under the action of a constant force. So acceleration is constant, force is constant, acceleration is constant. Then the distance covered in first 10 seconds is s1 and first 20 seconds is s2. Then what is relation between s2 and s1? That is the question. Okay, so oh actually I'm sorry, first 10 seconds the distance covered is suppose s1. Okay, and next 10 seconds the distance covered is suppose how much? It is let's suppose it is s10. Okay, so this will be equal to, I will write this as s10 to 20. Okay, I jumped ahead of myself, so this will be 3 times s1. And the question is distance covered in 20 seconds, not 10 seconds. So it will be distance covered in first 10 seconds plus the distance covered in next 10 seconds. So that means this is distance covered in first 10 seconds as 10, let's call it, which is equal to s1, and distance covered from 10 to 20. Okay, so it is sum of these two. So it is s1 plus 3 times s1. Okay, still it is directly based upon the Galileo's law of odd numbers. So S2 should be 4 times of S1, not 3 times of S1. If question was the distance covered in next 10 seconds, then it is just directly it is 3 times of S1, but question is distance covered in 20 seconds. So it is first 10 seconds, distance covered in first 10 seconds plus the distance covered in next 10 seconds also. So it is S1 plus 3S1. Okay, all right. So see, another question on the Galileo's law of odd numbers. Alright, let's move on to the next problem. A particle starts its motion from rest under the action of constant force. Another question, or I copied the same question. Okay, it's the same question. Let's move on to the next one. I'm sorry. A particle moves in a straight line with constant acceleration. It changes its velocity from 10 meters per second to 20 meters per second while passing through a distance 135 meter in t second. The value of t is okay. So velocity changes from 10 meters per second to 20 meters per second. Distance is given. Okay, so you can use this formula v square minus u square equals to 2 times a into s to find out what? To find out acceleration, because other three quantities are given. Okay, so let's do that, and we have to find time. So we can use another kinematic equation of motion, let's say v equals to u plus at, or v minus u equals to at. So once we know acceleration, we can substitute that in this equation to find out time. Okay, so first let's find out acceleration. So a will be equal to what? V square minus u square divided by 2 times s. Let's substitute the values. So values are 20 meters per second and 10 meters per second. So 20 square minus 10 square divided by 2 times the distance covered is 135, right? 135 meters. So how much is 20 square? 400 minus 10 square is 100. So 400 minus 100 is 300. 300 divided by 2 is 150. So acceleration is 150 divided by 135. We can simplify it, but let's see if we can solve this without simplifying. Okay, so here we want to find out time. So it is v minus u divided by a. Okay, so let's substitute the values. How much is v? 20. U is 10. So t is 20 minus 10 divided by acceleration, and we can directly substitute it. It is 150 divided by 135. So 135 will go into numerator. Okay, see, 135 is in denominator of denominator, so it goes into the numerator. So 20 minus 10 is 10. Then we have 150 in the denominator. So 150 divided by 10 gives me 15. So 15 times how much is 135? I guess it is 9. 15 nines are 135. Okay. So t equals to 9 seconds is the answer. Alright. So option B is the answer. And yeah. So yes, this is how we solve problems based upon one-dimensional motion. You can revise this topic, go home, revise this topic, try to solve more problems. So this is about it in this lecture. If you have any questions, I am waiting, or see you in the next lecture. If you have any questions, you can ask me. Yes. Are there any questions? Okay. Till the time somebody asks any question. So this is a crash course on NEET 2022. So we just covered dimensional analysis, error analysis, and today we covered what? One-dimensional motion. So it will be live at 8 o'clock in the morning every day. Yeah. So are there any questions? So I guess there are, yeah, please teach every concepts. Yeah. See, I am teaching all the important concepts in every chapter. Okay. So almost all the concepts I am teaching. Yes. Any more questions? But you have to revise it once again, and then please try to solve as many problems as you can. Okay, we are solving previous year questions. You can solve questions from some question bank, okay, from any publication, that doesn't matter, but solve many problems based upon these topics. So I hope now you can solve questions on one-dimensional motion or motion in a straight line. Okay, so if there are no further questions, I will stop here. let's meet tomorrow 8 o'clock in the morning. Okay, so thanks for watching this session, guys. Yeah, see you tomorrow. Bye.